Hello everyone, welcome to our series dedicated to space, atom and quantum. Today I'll talk about energy in space and how do we produce it. So, let's talk about energy. Why do we need energy in space? I think it is obvious. We have a lot of systems, electronics, we have a lot of consumption by humans. If we have a space station, we need lightning and so on and so on and so on. So, how do we get that energy? Well, when I'm talking about energy, I'm obviously talking about electrical energy. So you can say that it's electric. While it is electric energy, we also need to understand that electric energy doesn't come from noise. Electric energy is always produced by something or someone from other sources. For example, it is light energy converted to electrical energy. It can be heat energy. It can be physical energy, and so on and so on. So, how do we produce energy and why is it important? We talked about it. Let's talk about the problems of producing energy in space. Well, the first problem it is cost of energy. Very often, some sources of energy require a lot of money or a lot of resources that are not available in space. For example, some energy requires burning fossil fuels, which we obviously can do in space. Also, for example, solar energy requires solar wind, which we cannot access in space. So all of that energy is very costly to us, and we cannot have access to it. Second problem is safety. Often, safety of energetic sources are questionable because, for example, on coal plants there is radiation, there is dust that can get in our lungs and it generates lung cancer. There, in nuclear, it is obviously possibility of meltdown, possibility of explosion. So it's very how do you say it? It's very unreasonable to use not safe energy sources. Then it is availability of energy. While on Earth, a lot of energy sources are available, such as there is wind energy, water energy, there is energy of the sun, energy of the earthquakes, energy of the magma, and so on and so on and so on, energy of the ocean, energy of the tides and waves. In space, there are much less availability of energetic sources. There is no how do you call it? There is no wind, there is much less solar power, there is no magma, and so on and so on. So generating energy in space is also a big of a problem. So before we solve these problems, we need to talk about what types of energy do we have, what can we produce in space. So energy divides into traditional energy and alternative energy. Traditional energy includes fossil fuels and hydroelectric stations because hydroenergetics are were used commonly even before movement for clean energy. It is clean energy, but nevertheless, it is still traditional energy. So hydroenergetics and fossil fuels are both ways of generating energy in on Earth, but in space, obviously, we don't have this much availability, so they are out of the picture. So we can cross them off. Well, let's talk about alternative energy. It includes a lot of clean energy and also nuclear energy. So, alternative energy includes nuclear energy, solar energy, wind energy, wave energy, and biological energy. Uh, well, let's discuss about availability of those in space. Well, first of all, it is nuclear. Nuclear energy is uh, used everywhere on Earth and in space, but on Earth it is limited due to safety concerns, and in space it is limited due to fuel availability. But among all of this, nuclear energy requires a lot less fuels, so uranium rod can serve so long that we won't need to change it in the lifetime of our space station. Therefore, nuclear is actually a viable option for us. Then solar. Solar energy is also a very available source of energy in space, but unlike on Earth, in the space, solar energy is well, let's say, not as widespread. Why? Because on distance longer than Mars orbit, it becomes less available, and sun is less hot there. Well, feels less hot there. So solar energy is depends on our location and size. So maybe here solar energy is a little bit unsafe in space. I mean, unreliable. So we put a question mark on it. Wind energy is obviously not available in space, but there are some places where we can use it. For example, it is gas giant planets such as Saturn and Jupiter, but generally it is not usable. Well, wave energy is surprisingly widespread because on several planets it is usable. For example, it's usable on Europe, it's usable in Titan, but in Titan it's obviously not as good as on Europe because there is not water, but there's some other liquids. It can be used well on any satellite of any on any satellite of any on any moon of any planet as long as there is water. So, but it's still questionable. Well, bioenergy can be used widely on our space station because bioenergy requires byproducts of our everyday life. So maybe it can be our diet plants, it can be our used food, it can be anything that is biological and that burns. So we actually can use biological products on in space. So this is viable energy for us. Now, as you can see here, our viable options for us is nuclear and biological energy. But to talk about biological energy, we need to talk about our life on the planet. We need to talk about plants. So we will discuss it a bit later when we will discuss space and so on. So let's move on to the nuclear energy. So, nuclear energy is, as I said, it is surprisingly available source for us in the space, but also it is surprisingly safe. Let's talk about types of nuclear energy. Well, nuclear energy can be divided into two categories. It is fission energy and fusion energy. And fission energy divided into reactors and reactors. So let's talk about reactors first. So what is reactor? RTEC or radioisotope thermal energy generator is a device that, based on the name, generates energy from heat. How does it obtain heat? Well, the radioisotopes on board of this device are unstable and they decay. While they decay, they produce some amount of heat that then is transferred to energy. So, while this is widely used on space station, on spacecrafts, it is unsafe for human use because it generates electricity. So it generates, radiation. So we can't put this in our house, or we can't put this in a school, or in, I don't know, in a city, because it will just kill everyone and give everyone cancer, just like the Ninja Turtles and radiation from Cognito Inc. How is it called? Inside Job, yeah.
You just gave those turtles cancer!
So, yeah, so we can't use it at home because it generates radiation. Everything generates radiation, but this generates unprotected radiation, and thus it is used on electronics widely. Some missions that use this include Voyager, Voyager missions 1 and 2, New Horizon missions, and Perseverance missions. So, while we cannot use this on space station, we can use it for our additional bases that will be located on our, I don't know, moons or somewhere else. So RTEC cannot be used to generate electricity for the station. But let me show you something interesting. Okay, honestly, I just wanted to brag about it, but I have this model of Perseverance rover, and you can see RTEC here. It is placed in the back of the rover. Why? Because if it was placed here or somewhere here, it could have harmed the rover. So while we cannot use it on humans, we can use it for robots and rovers and so on. So yeah, like this. And it has a movable arm. Look at this. It has very much movable arm. Well, I'm not sure if it should move that way, but it is movable, and it is great. So let's talk about reactors. So while this surely looks as a volcano, it is also it's actually a excess heat tube for nuclear energy. So what is nuclear energy? In the form of reactor. So basically we have some rods here. Those rods are made from radioactive elements, so plutonium, uranium, and maybe, I don't know, radium, and so on and so on. So they are made from radioactive elements. And what do they do? Well, let me finish. So this water, these rods, they are covered with water, This water serves as a protection from radiation for the human because it blocks radiation, but also it heats from here. So while it heats and it evaporates, it spins the turbine located here. So this turbine spins, and because it spins, here it generates electricity. And because it generates electricity, we can basically supply whole chain with electricity. What positives of this method? Well, considerably, it is very cheap because we need only some fixed amount of uranium, and it can run for 100 years. Yeah, it will need maintenance, it will need service, but basically it will run for 100 years if used correctly with a fixed amount of uranium, and this amount is not that big as you may think. It may be measured in tons and maybe even thousands of tons, but it's still cheaper than coal or any other energy source. So then if it's cheap, by the way, it is also very reliable because there are almost no points in which this can lead to failure. Despite our knowledge of Chernobyl and 3 Mile Island and Fukushima, there's been only 3 major accidents in the history of the nuclear energy for about 80 years. As an example, it's I think it's a lot less than even aviation accidents. So yeah, basically the nuclear energy is very, very safe. I think it is safer than coal energy, much more safer than coal energy. So it is safe and reliable, but it is very, very what's the problem with this? It requires water and it consumes a lot of water. So we will either need a system that will reuse this water, or we will need constant water supplies. Both of these are very bad for us because we don't need to deal with that. We don't want to deal with that. So what do we do? Well, what do we do with the water problem? Well, of course, we can mine that water, or we can reuse water from the station. But beside of this, there is no solutions to this problem. So while this is definitely better than any previously given methods, it's still not the best option. Well, let's talk about the best option. Let's talk about nuclear fission. I'm sorry, not fission, nuclear fusion, as in Fusion 360. So, what is nuclear fusion? Well, basically, while doing nuclear fusion, we have our atoms of I don't know, helium. We widely use helium for it. Well, we can use ions of helium. We can use just helium. It doesn't matter. So what do? We basically collide those. We collide those with each other, and while they collide, they produce another atom. So we produced another atom, and while we did that, there was an excess neutron that was irradiated from here, and this neutron is basically, it carries a lot of energy of this fusion, and when it hits the wall, it either directly transfers it to electricity, or it may hit the wall and this heat is then transferred to electricity. This requires, as you can see, this requires helium in large amounts, but we have helium widely available for us in a lot of places in our universe, because it is a second most common element after hydrogen. So when we can use this helium, we produce a lot of energy. But what are the negatives? What are the positives? First, it is extremely efficient. It generates a lot of electricity. It doesn't require any rare resources, so it doesn't require any uranium or any fossil fuels or so on and so on. But also another positive, it can be used to create new elements that we need. For example, if we have if we don't have iron, we can create iron here, because it generates iron needed. So while this creates energy, it has negatives. What are the negatives of this energy method? First of all, it requires energy beforehand. It requires energy to start. You may know that in the stars, we have a star here. Let it be the red sun, I don't know. Whatever. So here, this reaction appears because of forces of gravity that pulled that mass together. This mass is pulled together by the gravity of the star, therefore they collide without any additional energy. But we don't have the gravity of the star on our station, so we need to launch those elements into each other using, for example, magnetism, or we can use lasers and so on and so on. But the point is, we need energy to start it. We also need technological advances. Right now, we don't have enough technology to create a nuclear fusion. It nevertheless can be used on a space station, theoretically, in Space Settlement Contest, because this is theoretical contest, and on theoretical contests we can use theoretical knowledge. It still requires a lot of technology, and another major minus is that if it goes out of control, it will create a nuclear explosion, and not just a nuclear explosion that we are used to, that occurred in Hiroshima or Nagasaki. It will create a Tsar bomba levels of nuclear explosions. Well, because it is nuclear fusion that are on its power level are equal to hydrogen bombs. And well, we don't want to have a hydrogen bomb explode in our space station, but it is still mildly safe. So while we have these three options to use as nuclear energy, we can conclude that those are the best options. In the next video, I will talk about alternative ways to create energy on the space station that include using human energy. It includes using chemical energy, so on and so on. So yeah, thank you for watching. See you in the next video. Goodbye.